Before we start our rig, we're going to define our Houdini digital asset. And the easiest way to do that is to just start with a subnet. And I'm going to give this a name and right-click, Create Digital Asset. This dialog will allow us to create the name, the label, and tell Houdini where to save this library to. In this case, I'm going to use soldier, and then I'm going to use 2 colons and say 1.0. This will allow me to version my asset. So if geometry changes or some functionality changes, I can increment this and keep track of different versions. For the label, this can be anything you want. It's not really important to match these two, but in this case, I am going to take off the version. And then the library is going to be saved to my desktop. I'm just using my desktop for the purposes of this tutorial. You'll want to save this somewhere a little safer. But for now, I'm just going to say soldier. And inside this soldier directory, I'm going to create a directory called HDA. And then here, soldier.hda. And then I hit accept, and I'll get this edit operator type properties dialog. And this is where we'll be able to define all of our parameters. We'll be able to add some code. We'll be able to add extra files. And then on this basic tab, we can see that our label is soldier, and we can change this at any time. We can see that we are saving the library here to the desktop soldier HDA. And then importantly, minimum inputs and maximum inputs. Minimum inputs should be 0. We don't ever want to force the user to have to put something into our soldier. But maximum inputs, I'm going to put it to 1 and hit apply and accept. And that will give us this input here. So if we ever have a transform that we need to send to override where our soldier is, let's say we've attached this soldier to a vehicle or something, you can use this input here. And we can go inside and we can see that this is the node that represents that incoming input. Up on our parameter panes, we can see that we have a transform and we have a subnet. But we don't want to transform our HDA. I think of HDAs as being a world, and we want our world for the HDA to match our world of our scene. So we're going to lock all of these. And this will prevent accidental scaling or transformation. And then back in our operator type properties, we're going to select the transform and make it invisible, and the subnet, make it invisible, and then hit accept. And that will clear these out. They're still there. If we show invisible parameters, we can see them and we can modify them if we need to. But we can just get rid of them for our user. Now that we've created our HDA, let's dive inside and attach to this incoming transform just a null. And we're going to call this null hidden transform. I'm going to turn off its selectability and its visibility. And the reason I add this is that even though our user, our animator, is never going to use this transform, having a transform above any of the actual rig transforms allows, in some extreme cases, maybe a layout artist or an animator or someone to go in and not touch any of the actual animation, but to move our character. So let's say that a character has been set up in relationship to an environment or to other characters in a camera, and the whole thing needs to be moved around somewhere for some reason. This will allow that movement without affecting any of our animation. So before we start rigging our character, it might be a good idea to bring in our geometry so we know what we're doing. So I'm going to bring in our soldier. So he's got a geometry node. I'm going to turn off the selectability of this. And inside is just a file SOP pointing to a location on disk. And to start with, I'm going to use a null, wire it straight into the hidden transform. I'm going to call this master. And I want the control type to be circles and on the XZ plane. And then in order to make this larger, I'm not going to use the scale on the Transform tab. I'm going to use the Display Scale. And I'm just going to put that at, let's say, 2.5. We're going to try our best throughout this tutorial to promote parameters as we go along rather than having to do a whole bunch at once. So I'm going to promote on this master control the translate, the rotate, and the uniform scale. And I can do that just by right-clicking here in this path and say type properties. And I'm going to bring a folder in from the create parameter area. I'm going to name this folder master. And then just drag and drop the translate, the rotate, and the uniform scale. You'll notice that they have a T2 here, so translate to. That's because there is already an existing T parameter from our original OTL or HDA transform. So I'm going to rename these. And hit apply and accept. And now you can see that on the master null, the translate, rotate, uniform scale have been promoted. And if we go to parameters, we can see that we have these promoted, and we can scale and use those parameters. I'm also going to lock the scale, pivot translate, and pivot rotate parameters. Parameters that we don't use, it's a really good idea to lock them off just to prevent any accidental transformations. Much later on in this tutorial, I'll be writing a script that will allow us to select a node and just click a button, and that will go through and find any parameter that doesn't have a promotion link here. It'll just lock them off automatically. Now we can start building our spine. In order to do that, we're going to come into the side view and draw the spine here through the torso, but my arm is in the way. So I'm going to go into the soldier body, and I'm going to use a clip sop. And I'm going to set that to X and below the plane. I can use this to just clip out that arm, which when we go back into the side view will allow us to see our spine, our torso without any distraction. So to build our spine, we're going to use the bones tool, and it's important to look up here in the toolbar for our bones tool. Here we can set the chain name. This is the prefix for each of the bones that we're going to create. We can decide on kinematics while we're building the bone chain. But then placement is pretty important. Right now it's on view-based. And what that will do is it will detect the geometry underneath our cursor and fire a ray from that piece of geometry through to the next piece of geometry. So it'll find this thigh, for example, and it'll put the bone right in the middle. But in our case, we want the spine right through the center line. So we're going to change that from view-based to freehand. And then up here where it says chain name, we're going to say spine. And then we have no kinematics. I'm going to start my spine, I think right about here. And if I click once and drag out, we have one bone. But you'll notice that now that I've activated the tool, this divisions parameter up here has been activated. And right now it's set to 1. So that means there'll be one bone created. But if I use my scroll wheel, you'll notice that I can change the number of bones. And you'll see that the number of bones in the viewport changes, but also this divisions change. So I'm going to set this down to 6. And then go pretty straight, right about there I think will be all right. And just click once. And now if I click off, you can see that I can create another 6 bones. Or I can just right-click and say Finish Drawing. And now you'll see in our viewport, we have a spine root, which is a null at the base of our bone chain. And then we have spine underscore bone 1 through bone 6. I'm going to rename our spine root to be just spine root. Take off the 1. And then while I'm still in the bones tool, I'm going to change that to pelvis. And we're going to build a pelvis bone just sort of back and down a little bit. So you'll notice that in the bones tool that each of our bones have a little square blue thing. And if I head over here and mouse over, now you'll see that I now have an XYZ prompt in my cursor. And what that enables us to do is we can now select one of these bones like that. And now I can move it around in the bones tool. So this is repositioning the built bones that I have like that. But I don't want to do that. I want to draw right from here down to the pelvis. But how can I do that when if I click here, it's going to select that bone? Well, the way to do that is to use the B key. And that will temporarily hide these little blue selecting things. So I can use the B key and just select there. And you can see that it remembered that I wanted 6 divisions. But I can just scroll that down to 1. And I'm going to put the pelvis bone about there. Now you can see I have a new chain with a new root. And in this case, I'm going to take this one off and this one off. And now that we've finished with our spine, we can hit Escape to get out of the Bones tool. Now what we want to do is create an IK control. And how we're going to do that is using the Path tool. So in the viewport, you can type Path, Create. And the path we want to create has 3 control vertices, one at the root, one at the center of our spine, and one at the tip of our spine. So here, here, and here, and then we can right-click and finish drawing. And now in our network, you can see that we have 4 new objects. We have a path object, and we have 3 path CV objects. I'm going to rename these to spine path. I'm going to rename this first one down here to be spine hip CV, this middle one to spine mid CV, and this last one to spine chest CV. It's worth taking a moment to examine what these things are and how this spine path is being built. So to do that, I'm going to hide my bones and geometry. And if we turn on points, we can see that each of these spine CVs is actually just a null that's been scaled non-uniformly. And how the path is being built, you can see if I rotate this, you can see I have a kind of a Bezier path being built here. If we go into the spine path, we can see that at the very top, all that's happening is that we're merging in the points of those CVs. So these points are being brought in for each of these nulls. And then if you look at here, the top and the very, very bottom, we're deleting those 2 top and bottom points, leaving just these. And then these are connected with an add SOP. We turn off. And then that is being converted into a Bezier curve. And so when we rotate one of these, the point at this bottom CV that's being retained is being used kind of as a tangent handle. And that's controlled by this scale parameter here. So we can make a very broad or very narrow curve. And what we're going to do is actually delete a couple more of these points, because we're going to convert this not into a Bezier curve, but into a NURBS curve. So I'm going to use a delete. And in this delete set to points, I'm going to delete 0.2 and 0.4. And what that will leave us with is a NURBS curve that can be controlled from this CV rotationally as well as transformationally, and this one at the hip, which will be able to rotate and change the shape of the curve. This mid one will only be able to translate around. So rotating this one won't have any effect because we'll be removing these 2 points. And those 2 points are 0.2 and 4. And now we connect that back in, change this from Bezier to NURBS. Make sure that display is on. Oops. Go back up, turn off points. I can hide these for a minute. So now if I rotate, you can see that that's the IK control that we're going to have on our spine. If I move this guy, rotation doesn't have any effect, but translation will. So we can move the middle of our spine around with that control. I'll turn these back on. We're going to be using this path to drive our spine. So we want to make sure that these path CVs are in exactly the right spot. So to do that, it's simple enough to show our bones again. I'm going to take all of these path CVs. I'm going to turn on keep position when parenting. And then just parent them to the positions I want them to be in and extract their pre-transforms. So in the case of this hip CV, I want it to be right at the root of the spine. So you can see that it's off by just a tiny amount. So I can set those to 0. And then this rotate X should be 90 degrees. So let's take that off. For the mid CV, should be right there at the root of bone 4. So again, extract that pre-transform. Tiny little amounts in translate and in rotate. So now it's exactly where that bone rests. And then for the chest CV, I want it to be at the tip of this last bone. So when I extract this transform, I'm going to remove the rotate, remove the translate in X, but this translate in Z I want to keep because I don't want this to be positioned at the root of the bone. I want it to be positioned at the tip of the bone. So how do I get that value? Well, I can go to the bone, to its bone tab, and there I can get the bone length. So I'm going to copy that amount and paste negative that amount into the path CV, and that will place it exactly at the tip of this bone. And then we're going to remove all of these connections. You can just hold Y and cut. So now each of these is free to be placed into our control hierarchy, but they'll be at the correct positions for our bone hierarchy. Now we can start building the IK controls for our rig. So I'm going to start with 3 nulls, and I'm going to call the first one hip IK, second one mid IK, and the third one chest IK. And just like we did with our path CVs, we want these to be just in the right spot. So with the hip IK, I'm going to parent it to the spine root, so it ends up right there. Then I'm going to turn on keep position when parenting, and now cut that link. For mid IK, going to go to the root of spine bone 4, so it's right there. Keep position when parenting, cut that link. For chest IK, I'm going to go to the root of spine bone 6, and then I'm going to, again, find that bone length. I'm going to copy that value, place the negative of that into the translate Z, then keep position when parenting, and cut that link. And now these 3 are in exactly the right spot to drive the spine CVs, which will drive our spine path, which will eventually drive our spine. So while the position of our IK controls are in the right spot, their orientation isn't what we want. If we look at the chest IK, we can see that it's pointing down in Z and forward in Y. And what we want is for these to be oriented in the world space. So the easiest way to do that is to grab all of our IK, extract the pre-transform, and we know that the translates are correct to place them in these positions. But the rotate, we just want to ensure that that's 0. And you can see that now the chest, Z is facing outward, Y is up, mid, Y is up, hip, Y is up. And then we're also going to change the display of these IK controls. So on the miscellaneous tab, we're going to change it from a null to, let's say, a box. And we can make that box much more narrow and a little bit smaller. And it would help if we turned on our body to give us a better indication. So that looks pretty good for our hip. For our mid, go down to box, scale that down. Whoops. Maybe a little smaller. Scale that down a little bit. And then for our chest, again, box. Scale that down. Scale it overall just to approximately where our shoulders are. That should be pretty good. Now that we've done that, let's turn off our body again. And let's also turn off the display of our spine CVs. And let's parent them to the controls that we want to control them with. So spine CV, key position when parenting, make it a child of the hip. Mid CV, its key position when parenting is on, make it a child of mid. And then the chest will be the parent of the chest. And then this spine path, we want to make this the child of the root, so that as our root moves through the world, it will take this path object with it. So now that we have our IK controls set up, let's now bind our spine bones to that spine path. And to do that, we'll go back into the Bones tool, and up in the Kinematics dropdown, we'll choose Follow Curve, and then we'll right-click in an empty space in the viewport and select Add Kinematics. So that tells the Bones tool that we want to add kinematics, and the type is Follow Curve. So now, down in the prompt here, you may have it in your viewport. I have mine in the status bar down here. It says select the first bone of the bone chain and press Enter to continue. So I'll select spine bone 1, Enter to continue. Now it says select the last bone of the bone chain and press Enter to complete. So spine bone 6, Enter to complete. And now it's asking for the curve object, and that's our spine path. So I select that and hit Enter in the viewport. And now you can see a new node is turned up. Here it is here. It's a chop network called Kin Chops. You can leave that name, it's fine. And if we go inside, we can see that we have an inverse kin chop called Kin Spine Bone 1, and it takes that name from the first bone in the follow curve. You can see that our root bone is spine bone 1, our end bone, spine bone 6. The curve object is soldier spine path. So we can go back up. And now if we hit escape to exit out of the bone tool, and we select one of our IK controls, you can see that our spine is now moving with our curve. But you can see that I can stretch the spine way out, and the bones maintain their length. To drive the length of our bones, we're going to be using an expression called arc length. And where we can test that out is if we just select one of our bones, and then here in the bone length parameter, you can enter into it and select Alt-E, and that'll bring up a little expression editor. So the expression that we're going to use, if you go to Windows HScript text port, you'll get this little sort of shell-like thing. And you can type xhelp and then the name of the expression or function that you're looking for. And if it exists, you'll get the documentation for it. And so this is the arc length function here, and it returns the arc length of a curve between two U positions. So we can use We can just actually just grab this whole thing and replace the current bone length with that expression. And then we can just fill in the proper values here. So in the case of the surface node, what we want is our spine path. And helpfully it attempts to fill that in for us. So we can just look down this list for spine path. And then the primitive number is just, in this case, 0, because there's only one primitive in our path node. And then the uStart and uStop is the place along the curve that we want to start and stop. And in our case, that's 0 for the beginning of the curve and 1 for the end of the curve. We want the whole curve. So we can hit apply and accept. And now you can see that the bone is much larger than it should be. Well, that's because we need to take this value and divide it by the number of bones that we have, because this length is the entire length of the curve. So we can just say divided by 6. And now our bone is still the same length. We can test that by toggling the expression or value display, and we can compare that to another bone. So those are the same, well, almost exactly the same length. So what we can now do is we can copy this and we can paste it into all of our bones. And now the bone lengths are going to be 1/6 of that curve length. So if we take our IK control and if we stretch that curve, our bones are going to stretch. So instant squash and stretch right there. So now that we have our IK all set up, we want to add the FK control to ride over top of this. So again, we're going to create 3 nulls. And the first null we're going to call spine A FK. The second one, spine B FK. And the third one, unsurprisingly, spine C FK. And just as we did before, we want to use our existing structure to place these nulls right where they should be, because right now they're just sitting at the origin. And where we want them is to be down here at the root, and then we want one after the second bone, and then after the fourth bone. So sort of right in between our IK controls. So for the spine A control, we'll use the hip IK location, keep position when parenting, and then cut that link. Spine B, we want it to be at the root of the third bone. So we'll use the third bone, keep position when parenting. We'll cut that link. And then spine C at the root of the fifth bone. Keep position when parenting. Cut that link. And then again, we want to grab all these guys, extract their pre-transforms, so we know that their translations are correct, but their rotations, we have to force that to be 0. So now when we select them, Y is up, Y is up, Y is up. And then, just as we did with the IK controls, we're going to change the display of these guys. So we can select all 3 of them, go to the Miscellaneous tab, change the control type to circles, change all planes to ZX plane, and then we can resize these. Again, we can turn our soldier back on and size these to fit depending on our preferences. We can move these around and change them however we want later, but for now this will be fine. So now that we've built our FK controls, we can parent spine B to spine A, spine C to spine B. So now we get nice rotation. And just so that we can differentiate these a little bit, we're going to change the colors of these. So our FK, we're going to go to the miscellaneous tab, look at wireframe color, and then let's choose this sort of bright blue. And on our IK, I'm going to choose a sort of a cream color, just so that we can easily identify the difference between the IK controls and the FK controls in the viewport. And now, before we hook up our FK control to our IK control, I'm going to make another sort of master null type thing here. So a null parented under the master, and I'm going to call this one COG. So that stands for center of gravity. And I want to place this null somewhere in the middle. It's really up to you. Belly button is usually a good place. This guy's got kind of a low belly button. So I'm going to put it just here in between these two FK controls. And I'm going to change its color to something fairly prominent, like, yeah, red is fine. Then we want circles on the ZX plane. I'm going to make it kind of large. So that's the center of gravity for our whole character. So selecting and moving this around is going to move the whole torso, but it won't move the IK on our feet and wrists. So it goes right below the master. Now we're ready to assemble our rig. I'm going to start with the center of gravity, and I'm going to clean its transform. The center of gravity is going to be the parent of the spine AFK, and the spine AFK is going to be the parent of the hip IK. The hip IK is going to be a parent of the spine root and the pelvis root. The spine BFK is going to be a parent of the mid IK. The spine CFK is going to be a parent of the chest IK. And now we can test to see if any of this is broken. I'm going to start with our center of gravity, and this control is going to be able to translate and rotate. So if we rotate it, you can see that all of our controls for the spine and torso are coming along with it. We can translate it as well. Our hip IK is just going to be a translation and also rotation. We can see that it rotates, it translates. Our mid IK is just going to be translation. And there's our chest. We can translate and rotate. And then our FK rotates. So that's great. So there are a couple of things that we need to finish up before we're done with our spine. One of them is to go through each of these controls and not only clean up some of the transform values that are here, but also determine which of these parameters we're going to promote to our HDA to allow our animators to access just the parameters that we want them to be using. So we're going to start with, well, the master we've already done. So now we'll do the center of gravity. And this one is going to have translation and rotation. So here on the soldier, I'm going to open the type properties. And I'm going to create a new folder. I'm going to call that spine. And then I'm going to promote from the center of gravity, I'm going to promote the translate and the rotate. And then I'm going to lock everything else. So here, I'm going to name this cog trans. Cog rote. I'll go through and do the rest of these, and then I'll come back and show you what I've done when I'm finished. All right, I've promoted all of the parameters that I want for the spine FK controls and the IK controls. And the naming conventions that I'm using here are really up to you. You can choose to do whatever you want. I like the center of gravity to just be sort of on its own, but I really do prefer all the other basic body parts, like the spine and the arms and the legs, to have a prefix of what that body part is. But you can choose not to do that if you want, just so long as that these parameters are easily identifiable. So I've gone through and I've made all of these. I'm going to hit apply and accept. And now you can see that each of the ones that I've promoted are locked. So let's go through these individually. Spine, AFK, BFK, and CFK. Everything is locked except for the rotate, and that's been promoted. For the hip IK, mid IK, and chest IK, everything is locked except for the translate and the rotate. Another thing that I like to do is in the network, you can see that from a little ways away, we can kind of identify bones easily because they have that kind of cream color and sort of darker color for the kin chop network. But our actual controls are a little hard to identify. So what I like to do is to just, in the network, take controls that actually have a channel reference on them. And that would be just these. And I like to color them in the node editor. And you can do that just by hitting C on your keyboard with your mouse in the network, and you can bring up this color palette. So I'm going to grab all of these controls, and you could differentiate between FK and IK if you wanted. I don't find it necessary personally. And I'm going to choose this sort of darkish green, because it kind of matches the green of the promoted parameter. And then just hit C when you're done. Additionally, I'm going to go through and, at least temporarily, turn off the selectability of all the bones, because we really shouldn't be touching them at this point. If we want to move a bone, we have lots of rig stuff to move our bones. And additionally, the path selectability and visibility, the root nodes of our two chains, selectability and visibility can be turned off. And I think that that's just about it for our spine. So we have a functioning spine, but you'll notice that when we use it, we're not getting any kind of activity in this mesh. And we'll go through a method of chopping this up and creating proxy geometry so that we're not deforming the geometry, but the animator will see this geometry being animated in the viewport. And we'll do that next. Before we build our proxy geometry, there's a little thing that I forgot, and I seem to forget this every time I build a rig. And that is, we haven't made a control for our pelvis. We have a hip IK control, and if we rotate it, we can see that our pelvis bone is rotating. But we don't have an individual control just for the pelvis. And the easiest way to do that is to use this null that we have when our pelvis bone was built. We got this pelvis root. So I'm going to turn that back on. I'm going to give it a green color because it's going to be something that we can animate. And I'm going to promote its rotation. I'll call that accept, lock all this stuff. And then for the control itself, I'm going to go inside and I'm going to paste a little network and wire it into the control SOP. And all this is a sphere and a line, and then the line or the sphere has been copied to one of the points of the line, and then those two things have been merged together. I'll show you what that looks like. So we have just a primitive sphere. Then we have a line that has 2 points. And then we're copying the sphere onto the first point of the line. And then we're going to merge those two things together. So we get a ball and a stick. And then we feed that in as the input to the control SOP. So now we just have to go up and on this null, change this control type to circles to control SOP input. And now we get this little ball on a stick, and we can use that to control our pelvis independently. And you could go inside and change the direction of this line to change the angle of that line and ball. But I kind of like it the way it is there. And you can see that when we rotate our hips, that will come along for the ride, but then we can still go in and rotate the pelvis independently if we need to. For our proxy geometry, what we're going to be doing is creating a new geometry object here at the object level and filling that with a piece of geometry from our mesh, and then parenting it to each of these bones, so that as we manipulate our rig, we'll be rotating a bone, and that bone will be a parent of a piece of geometry, and that will move in the viewport. And rather than have you sit there and watch me doing this, because it's kind of a tedious process, I'm going to go ahead and complete the proxy geometry for the full spine, and then I'll come back and I'll give you an overview of what I've done. It's all very simple, but as I said, it's tedious and boring to watch. So I'll come back in a minute and show you what I've done. To make the proxy geometry for the spine, I first made a geometry object for each of the bones, for the pelvis and all the spine bones. And I named them the respective bone name plus proxy, and colored them purple because proxy starts with P and purple starts with P, and they're easy to identify. And then what I did is I went into the soldier body, and you can see I've turned him off now. But inside, off of the main soldier body mesh, I just made a bunch of groups. And those groups align with approximately the bones that I want to move them with. So in this case, pelvis, spine 1, spine 2, spine 3, 4, 5, and 6. And you don't have to be super precise about these. They're really just to give a general indicator for the animation department of what their rig is doing and what the final deform is going to be looking like. So you don't have to really worry about, should I put these polygons into the group or not. You don't have to spend that much time on it. After I did that, inside each of these proxy objects, I used an object merge, and I pointed it to that soldier body geometry. But then I used the group field to specify the group that I wanted. So in this case, spine 1, since I'm in spine 1 proxy. And so I get just that piece of geometry. Another way to do it would be to use deletes inside the soldier body and to delete off bits of the geometry. But I find groups are easier because they're easier to change later, and then this will just update. And then I follow those object merges with a null that I've locked. And the reason that I've locked it, if we go up and look at this pelvis, and if I unlock this, everything still works. But if I rotate the hip, the pelvis doesn't follow. The pelvis controls follow, the pelvis bone moves, but the pelvis geometry doesn't. And the reason for that is that for every instant that I am updating the rig, this object merge is recooking. And so it's moving because its parent is moving. Then it's recalculating, well, what is the soldier's body? Where is the pelvis group? Bring that into this object. And that is changing every time. So in order to prevent that, I just use Control-click on the red flag to lock this geometry. And we'll be dealing with this in a better way, a more pipeline-friendly way later on. For now, this is fine. But now that I've done that, these proxy objects, whoops, looks like that one's broken. Which one is that? Oh, there we go. Yeah, that's got it. So now we get a nice indication of how our spine is moving. We can see a nice twist. Next, we'll make some groups for our controls and our bones and our proxy objects. And we'll make them here in the network using node groups. And then we'll edit our parameter pane. Right now we just have the master, we have the spine, but it would be nice to be able to turn some of these things on and off in the viewport, because this can be somewhat cluttered. So we'll see how to deal with that next. At the moment, we only have a dozen or so nodes in our network, and it's pretty easy to tell what's what and to select the ones that we want. But once this network grows to hundreds of nodes, it'll become much more difficult to manage. But one thing that will help is something called node groups. And with your mouse here in the network, if you type Shift-Z, you'll get this little drop-down. And this is where we can make node groups. And I'll make a really simple one just to show you an example. I'm going to select all the spine bones and the pelvis bone, and I'm going to drag them up into here and drop it. That's created a new group, in this case called Group 1, but I'm going to rename that Spine Bones. And you can see that there's a little yellow square here, and then a blue one, and then a brighter blue one, and these have some numbers in them. So if I have nothing selected, and I use this yellow square, you can see that I'm able to select all of the bones that are in that group. And this is really handy, because let's say I'm way out here looking at some other part of my network, and I need to select my spine bones. Well, I could zoom all the way in, select them, and then zoom all the way back to where I was. But I could also just do that, and you can see that I'm selected all of my bones. And additionally, it'll tell me how many nodes are in this group. So the spine bones is 7. So I have 6 here and pelvis bone. So I'm going to create a proxy group. Call this spine proxy. And then I'm going to create a spine controls group. I'm going to include the cog, center of gravity, in that group, but I'm not going to include the master. And you can open this window larger if you need to. And so now not only can I select these things using this node group interface. Oh, and I've forgotten the pelvis again. So I'm going to select my pelvis root, and I can use this little arrow drop down, and I can say add selection to group. So now the pelvis is also in there. And as you could see, I could also use this to remove a selection from group, or I could just delete the group entirely. But another thing over here, the D just here means display. So with nothing selected, I could go to the spine controls, and I could click the darker square here. And you can see that in the viewport, they've been turned off. And then I can turn them back on again by hitting the lighter blue here. So you can see that the visibility flag has been turned on and off. So this is a quick way of as I've said, if you're way out in the network or just in another place, even if you're zoomed in, but maybe you're over here doing something and you need to turn off all of the spine controls for some reason, you can just open up the node group with Shift Z, turn them off, turn them back on again. It's very convenient. So we're going to be doing that for all of the different sections of our rig, for the arm and the hand and legs and feet and the head and the neck. Now we're going to improve the look and usability of our parameter interface. Currently, our Soldier HDA has a master tab and a spine tab. And we just have the basic transformation parameters in here. But what will be useful is to have parameters that will turn the master control on and off, that will turn the spine controls on and off, turn the bones on and off, and the proxy. So we'll add those now. In our type properties, you can see that we have our master folder and a spine folder. And then we have our three master controls. Oops, and this one is spelt wrong. Correct that. What we're going to do is we're going to add 3 folders to this master folder. And the first one we're going to call m_display and a label display. And then we're going to select it and hit D to duplicate it. And you can see that it tries to reuse the name, so it put a little 2 after M display. And that's all right. We can probably change that later. But for this one, we're going to give it the label of controls. And then we're going to duplicate this one. And we're going to call this one actions. And right now, these 3 are in fact controls. So I can actually select those and then drag them into the controls folder. And if I hit apply and then look at my parameters, you can see that we have in our master folder, we have a display folder, a controls folder with our 3 controls, and an actions folder. Display and actions are empty right now. And that might be fine. You might be comfortable with having these little tabs. But sometimes I prefer to have them all displayed in a single column, but with little decorators to differentiate them. So the way I'm going to do that is I'm going to change the folder type on each of these from tabs to simple. Simple. And for some reason, changing the folder type has allowed me now to change these names. So I'm going to change these names to controls, M controls, and M actions. The name of the folders aren't all that important. If you're not able to change the name, don't worry about it. You're rarely going to interact with these folders by name. For our users, the label is much more important. So now if I hit apply, having changed these to simple, you can see that we've lost our display and actions, but our controls now is a little label on this kind of group field here with a little border around it. And the reason that we don't see anything display or actions is because they're actually empty. So we can fix that if we just add, say, an integer to each of them. And now we hit apply. And now you can see that this is how our controls are going to be displayed. So for the actions, I'm going to remove this one, and we'll get back to it later. And for display, I'm going to use this simple integer, but I'm going to add 3 more of them. First, I'm going to change the name of this to mDisplay. So this one is going to be called master display. Then I'm going to duplicate it, and it's going to be called gDisplay. Call this geo display. I'm going to duplicate that one. I'm going to call this B display. Bone display. And finally, C display controls display. I'm going to hit apply, and you can see that these are now integers. But I don't want to use integers. I want to use little drop downs. And what these are going to control is this one, the master display, is going to control whether or not we see this master control in our viewport. The geo display is going to drive all of the other tabs. All the other tabs are going to have a display for what type of geometry we see, whether we see the proxy geometry or the final deformed geometry or nothing at all. And so on the master tab, there'll be an overall geo display control. And then the same for bones and for controls. So that instead of going to the spine and the arm and the leg and the foot and turning all of these off and on individually, we can use the master display just to drive all those other tabs. So for each of these, I'm going to come over here to the menu tab, and I'm going to say use menu. Now I'm going to say that the menu item 0 is going to be off, and menu item 1 is going to be on. And now when I hit apply, you can see that our master display has changed from this integer to an off-on little combo box. So I'm going to do the rest and come right back. So I've finished adjusting the parameters for our other display combo boxes. So now the master display can be off and on. The geo display can be off, proxy, or deform. Bone display, off on, controls display, off and on. I'm going to take the geo display, bone display, and the controls display. I'm going to hit D to duplicate them. I'm going to drop them into the spine folder. So we're going to need these here as well. And I'm going to rename these for spine geo display. And just like in the master, I'm going to create 3 more folders. I'm going to move those to the top. I'm going to change all of their types to simple. And then, just like in the master, we have M display here. I'm going to say S display and call this display. Controls, so now we have S controls, call this controls. S actions, call this actions. And I can take these 3 display controls, put them into display. I can take all of our controls, put them into controls, and I can leave actions empty for now. We'll get back to that later. So now when I hit apply, we have master with display controls, and spine with the same display controls as master, and our controls are nicely grouped into this little region. Next up, we'll see how to use these controls to actually drive the visibility of these objects in the viewport. Before we use these parameters to drive our nodes, we'll want to have a look at the default values that they have. Currently the geo display is set to off, but what we really want is proxy. You can see when I change this, proxy becomes bold, and so does the spine tab. That's to indicate that these have non-default values. So what I want is for that to be proxy and not off. Also, the controls display, we want to be on by default. And the way that we can do that is to, in the type properties dialog, we can come to geo display, go to the channels, set that to 1. Similarly for controls display, set that to 1. And now when I hit apply, our spine geodisplay default is proxy. You can see off is non-default, proxy is display, and controls display is set to on. So now I can come over here and I can select all of my proxy geometry. I can come to the Render tab. We can drive this display parameter. We can do that just by clicking and dragging and dropping that and selecting relative channel reference. And while this works, if we set geodisplay to off, our proxy disappears. Set it to proxy, it's on. If I set it to deform, it stays on. And while it might seem like that's a good thing, it's actually not, because we don't want the proxy to be visible when our deform is visible. So if we look at the value that is being sent to each of these pieces of geometry, we can see that it's taking the value from this parameter. In this case, it's displaying 1, but deform is actually 0, 1, 2. So we need to fix that. And the way that we can do that is just with a simple expression. So let's just take the proxy first. So instead of just directly referencing this value, we can use an if statement. So we can say if, and then parentheses. So if that value equals 1, then 1, turn on. And if it doesn't, turn off. And close those parentheses. So now you can see that our proxy for our pelvis has disappeared, because this geodisplay parameter is not 1. It's actually 2. So off, everything turns off. Proxy, everything turns on, including our pelvis. But if I turn this to deform, that disappears. So we can use this expression, copy, and we can paste it into all the other proxy objects for our spine. And now you can see they all disappear because we've set this to deform. If we set it back to proxy, everything turned back on, off is off. So we'll continue and do the same to the bone display. We can just simply grab all our bones, go to the Render tab. In this case, we need to turn on, activate the display parameter. We can grab the bone display parameter name, drop it right in here, relative channel reference. And now bone display is off, bone display is on, so that's working just fine. And again, for the controls, grab all of our controls, go to their Render tab, turn on the display parameter, grab the controls display, drag, drop, relative reference, and now you can turn those off, turn the bones off, everything's off. Proxy, on. And there we go. We've finished our spine. Next we'll be building the rig for the neck and head. But before we do that, we're going to install a couple of shelf scripts that will help us perform a number of repetitive tasks more quickly. The first is a shelf tool that will lock the parameters that we're not exposing to the animator. And the second will be a tool that will build a set of nulls that we'll be using as control objects. To install the shelf scripts that we're including with this tutorial, come up to the plus menu here in our shelf and say New Shelf. And go to the options. And depending on the operating system you have, you should have a path similar to this. It will be Documents, and then the Houdini version that you're running, Toolbar, and then the path will be Default Shelf. But we're going to change that. We're going to say Rigging Tools. And then the name of the shelf is also Rigging Tools. And then the label is Rigging Tools. We can hit Apply. And now you can see that we have a new shelf called Rigging Tools. So we want to apply and accept. And at this point, we want to save and exit Houdini. And now, go to your Documents folder, and again, depending on the operating system you're running, this could be, if you're on Linux, your home directory. On Windows, it's Documents, and then the version of Houdini that you're running. And look for this Toolbar directory. If the toolbar directory isn't there, you can just create it. Then going inside, paste these two shelf tools, FK Controls 3, it might be just called FK Control, and Lock All. So having pasted those in, we'll start Houdini up again, and then we'll add these to our shelf. So if we click our rigging tools shelf, we can see that currently it's empty. But now we can right-click in an empty space here and say Edit Shelf Tab. So this brings up our Edit Shelf tool again with our options. But now if we go over to Tools, this lists all of the tools that are offered in Houdini. So you can add any of these that you want to this shelf. The ones we want are the ones that we added just a moment ago. FK Control, Lock All. So you can just select each of those two and then hit Apply and Accept. And now you can see that FK Control and Lock All have been added to this rigging tools shelf. So we're going to start with Lock All. I'm just going to place a null here in the network. If you'll remember from when we were building our spine, some of these parameters we were promoting, and so they were getting a channel reference. Here I'm just keying to represent that. And then we were manually locking each of these, and that was kind of time consuming. And in a rig you could have hundreds of nulls and hundreds of bones. So doing that over and over again is really laborious. So if we look at this Lock All script and we can right click on the tool and say Edit Tool, you can see that its name is Lock All and the label is Lock All. And then if we go into the script, you can see it's fairly simple. It's just doing a little loop. So all of the shelf tools know about whether you control click on them or shift click on them, and then there's a number of things that you can do there. So I usually just add this little boilerplate here automatically. But the meat of the tool is here. So we get the selected node. So when we select a node, that will be put into this nodes variable. And then we have a series of parameters here listed as translate, rotate, scale, pivot, translate, pivot, rotate, and scale. So that's these guys here. And what we want to do is we want to lock them, but only if they don't have a keyframe or an expression. So in this case, we have some keyframes on our rotate. So we don't want to lock these, but we do want to lock everything else. And you can see here I'm using control click. So if the user has control clicked on this lock all, it's going to lock 0, which means unlock. Otherwise, it's just going to lock. You can see I've selected the node, and then I come up here to lock all. You can see all of these have been locked, but the rotate parameter has been left alone. And if I wanted to undo that, I could then simply select again, and then with control held down, click lock all, and it will unlock everything. And again, it'll leave the rotate alone. So that'll be super useful for us throughout the rest of this series. Boom. Very fast. The next script that we're going to look at is this FK Control. And it's doing a lot more stuff, but it's all pretty simple. Essentially what it's doing is it's getting a selected node and just using that so that it can know where in Houdini it is. And then with this UI read input, it's going to put a little pop-up and it's going to ask us for a prefix. So we supply that prefix, and then it's going to use that prefix to create the names of the nodes that we're going to create. And we're going to create an offset node, an auto node, and a control node. And you'll see what those are doing when we're done. And then each of these sections is just the Python script to create those nodes. And then if we use control click, it's going to go and lock a bunch of those parameters. So that's sort of an option. So if we try this out, so we've selected a node, and now we hit FK Control. It gives us a little pop-up. So it's asking us for a prefix, so we can just say test. When we hit OK, now we get 3 new nodes with test, which was the prefix that we supplied. So we have a null that's test offset, a null test auto, and a null test control. And you'll notice that offset and auto are not selectable and they're not displayed. And also if you go inside, they're empty. Because we're not going to be using these interactively in the viewport, it's not necessary to have the control object and the point stop there. The test control, however, is something that we'll be using in the viewport, something that we can manipulate our rig with. So it's selectable and it's displayed. It's got a slightly different color, and then inside it's just a regular null. So you can use this script to create lots of things like this. And just by editing the tool and playing around with it, you can create different nulls. You can set their display, like in this case, the control type of our test control node has been set to circles on the XY plane. And that's orientation set 3 is for XY plane. But you can play around with this, and you can make new versions of this to do all kinds of other things. So we'll be using these quite a lot throughout this series, and they'll really save us a lot of time. So our spine is finished. In the next tutorial, we'll be doing the head and the neck. Thank you. Welcome to part 3 of our rigging tutorial. In the last part, we finished up our spine and made its parameter pane. So we have a master parameter pane, a spine parameter pane with some display options, and our controls promoted to the top level. In this video, we'll be doing the neck and head, as well as the eyes. And so our neck will have 2 rotational controls. Our head will have a rotation control. We'll have a simple jaw. In addition, we'll have this eye control, which we can move around, and we can move individual eyes if we need to. It'll also have this little indicator here to show where the eyes are looking, and you can turn that on and off. The head and eyes will also have space switching. So right now, if I rotate the neck, you can see that the head follows. But if I come over here, I can adjust this head follow parameter. So I can say right now the head is following the neck, but I can switch it to chest. And now if I rotate the neck, you can see that the head does this little sort of chicken thing, doesn't rotate. But if I move down to the chest control, now the head moves with the chest. And then I can go down to the center of gravity. So now moving the chest, head stays where it is, but I can come down to the center of gravity, and now it'll follow with that. And then of course I can go to world. Moving the center of gravity doesn't rotate the head. And the eyes will have the same thing. So right now the eye control is set to follow the head. So if I rotate the head, the eye control will move with it, but I can set that to world, and now moving the head control keeps the eyes looking straight ahead. And now with this set to world, I can come over here, I can grab our master control, and I can rotate everything, and the head and the eyes follow along with it. To start our rig, we're first going to come up to our type properties, and we're going to add the folder for the head and neck and eyes, and add their display properties. To start, we'll make a folder for our head and neck. So I'll take a folder drop it onto the root. It'll pop it down here at the bottom. You can name that. And then since the spine has a bunch of parameters that we're also going to have on our head and neck, we can just shift-click to select all of these. And we can just hit D for duplicate. That will duplicate them all. And then with all of these still selected, I can just grab them and move them into the head and neck. Now, the controls are going to be all different, so we can select all of these, just hit delete. So in our head and neck, we have a display folder, which again is set to simple, but we're going to change the name here to H display. Get rid of that extra number at the end. Our control folder is going to be H controls. Our actions folder, H actions. And then for our geo display, we're going to change this to HG display for head geo display. Get rid of that number. Whoops. Our bone display, similarly, HB display. And controls, HC display. And then we're going to need another folder for our eyes and for our jaw. So if we think of this as the head and neck in total, we need another folder at the bottom for our eyes. So we'll take that, drag it into head and neck. That goes here. We'll change this to simple. And we'll call this, what did we call this? Head and neck. We'll call this eyes. And then we need one for the jaw. So again, drop that in there. Jaw. And then our eyes also need some display controls because we need to control the visibility of the eye controls themselves. We need a control for the eye follow, whether it's following the head or whether it's following the world. We need a display control for our eye line. And we could also have a control for the display of the eyeball proxies. So we'll take all three of these, duplicate them, drop these into our eyes, change this to EG display for eye geo display. We don't have, we're not going to just have a toggle for our bone display. There's no real point in seeing those. So we'll just get rid of this. Our controls display will change to EC display. And then we need one for eyes follow. So we'll select one of these and duplicate it. And we'll call this E follow. Call this eyes follow. And then we need a control for the eye line. So we'll take eyes follow. We'll duplicate that. Call this eye line. And of course, I always forget something. And in this case, that's the jaw control. So we'll select our eyes control, duplicate it, drop it into jaw. Change this to JC display for jaw control display. And that is actually it. And something that I probably should have pointed out in the last video, and I'll try to point out throughout these videos, is that when you're editing your operator type properties, or you're making changes inside your HDA, and then you save your HIP file, what you're saving is sort of a temporary edit to your HDA, because the HDA exists in two states. One of them is here on disk, and if I middle click, you can see that this operator is being defined by the HDA in our soldier directory called soldier HDA. But because it's unlocked, I'm able to go in and make changes not only to the node network, but also to the parameter panes up here. These changes are stored just in this HIP file. They don't exist yet in our actual HDA on disk until we apply those changes or with the type properties, you can hit accept as well. And now this definition on disk is synced up to the actual contents of our HDA, including its parameter pane. You can see that the changes that we made to the head and neck now appear master spine, head, neck. And you can see that we now have these existing. And I just noticed that this jaw is set to a tab type, and it should be simple type, so I can go and make that change. Jaw simple. But you notice that this change hasn't occurred yet because I need to apply it. And now it's properly in line with these. So just a note about the difference between an unlocked HDA in a HIP file and the actual definition on disk. So keep that in mind, that if you're making changes to your HDA, you always want to apply those changes. So you can do that through that type properties dialog, but you can also right-click on an unlocked HDA and select Save Node Type. And now it's synced up. And if I now match my current definition, what that will do is it will match this node in this HIP file with the definition on disk. So if I make, if I do that now, I'll show you match current definition. So now this is locked. And if I go inside, you can see that I can select and move stuff around, but I can't edit. I can't really make any change because it's locked out. But if I right-click and say Allow Editing of Contents, now I've unlocked this HDA and effectively broken the link in a way with its definition on disk. So now I can go in and I can just make a big torus here. So now there's a torus inside our HDA. If I go up, and let's just move this guy. Well, let's attach this torus to our master control. So now if I move this guy over, see he's unlocked and he's not synced up with his definition on disk. But if I add another soldier tool or digital asset, you can see that this one is locked and synced up with its definition on disk. This one has the same definition on disk, but it's unlocked. And so these changes, specifically adding a big torus, won't show up here because I haven't applied this change. But watch what happens when I do. Save Node Type. Now, both of these have a big torus in them because I've applied the changes that I've made to the definition on disk. This one has been matched to its definition, and so it will update. And if I go back and delete this, again, this definition on disk has not yet changed, even though I've changed the inside of the node. So I need to apply that change if I want to save it. And that's completely independent of saving the HIP file. So now if I save the node type, you can see that our other instance, which is locked, has been updated. So keep that in mind. Now we can start actually rigging our head and neck. So currently we have our proxy for our spine displayed. So I'm going to go to the spine, turn off that proxy. And I'm also going to turn off the controls temporarily. I'm going to bring back the display of our soldier body. And I'm going to go into the side viewport and actually bring back our spine display of bones. Turn that on. So we're going to be making 2 neck bones, and then a head bone, and then a jaw bone. And we'll use our head as a guide, and we'll start at the top of the existing spine bone. So invoke our bones tool, and up in the chain name, we're going to use neck, no kinematics, and the placement is going to be freehand because we're in an orthographic viewport, and we'll just start right about here. So we have one neck bone to there, the next neck bone to here. We can move away, right click, finish drawing. Now in our network we can see we have a neck root 1, neck bone 2, and I'm going to rename this neck root, and then I'm going to continue from this neck bone. And remember, because of these little blue selector things, I want to use the B key, so that temporarily disables that and allows me to start a bone right here. So this is our head bone, and I think while I'm in this tool I can change this to head. I think this will work. So I'm just going to go generally straight up. You can be forward or backward, it doesn't really matter. And go there, right click, finish drawing, and it did work. So now we have a head root and head bone 1. I'm going to take the 1 off of the root, and now we're still in our bones tool, and I'm going to say jaw, and then I'm going to make the jaw starting right about here. Usually I go right where the earlobe, meets the head, somewhere in this general area. And we can adjust this later. Just to the tip of the jaw. There we go. We have a jaw root. Take that off. And hit escape in the viewport to get out of the bones tool. All right. Now, I don't really need this head root. So what I'm going to do is I'm going to select that bone. I'm going to keep position when parenting. And then I'm going to reparent the head bone to the neck bone 2. And I can get rid of that. So now I just have a simple 3-bone chain. And then the jaw root, I'm going to parent to the head bone. And because the jaw root has keep position when parenting, it's going to maintain its spot right here. It's not going to snap over to the base of the jaw of the head bone. And that's that. And now, just like we did with our spine, I'm going to go into the soldier body and make some groups for the neck and the head and the jaw. And I'll come back and show you what I've done when I'm finished. All right. What I did was, just like with the spine, I made a geometry object for each of the bones. I colored them purple and gave them a name that makes sense for this rig. So for neck bone 1, I made neck 0 proxy. I could have done neck 1 proxy and neck 2 proxy, but in this case I just started with 0 for some reason. And inside that, our object merge, again, I went out and found the soldier body, and then I specified the group that I made. So if we go over to the soldier body, you can see that here were our spine groups that we made. And then I made neck groups. So neck 1, neck 2, I made a group for the jaw, and then the rest is for the head. And then with this guy displayed, that will allow these object merge SOPs to be able to see all of those groups. So in this case, I just selected neck 1. Then I put an out node, and then I'm going to control and click to lock it. And again, we'll deal with this in a better way later on. But now I can just go in, lock that one, lock that one, lock our jaw. And now if I go up here and I turn off the display of that original soldier mesh. Oh, wait a minute. What have I done? Something's wrong here. Oh, there's our jaw. Lock that again. And what is this guy? There we go. So when you're object merging and locking, it's easy to accidentally lock one of them and then go and change your object merge. But of course it won't show up because you have this locked. So just unlock it, make sure your object merge is what you want it to be, and then just relock that node. Now we go up. And now if I grab these 3 bones and just rotate them, you can see that we have proxy geometry, just like our spine. And so next we'll make our controls. Before we make our controls, this is an opportune time to test out our lock all shelf button that we made. because each of these proxy objects has a full transform, but we don't want this stuff to transform at all. So I'm going to select all 4 of these guys. I'm going to come up to my Lock All Shelf tool and click Lock All. And you can see for each one of these, it's gone through and just locked all these parameters. So I don't have to do that by hand. So awesome. The controls for our neck, head, and jaw are just going to be simple rotational controls, and they're going to be at the root of each of these bones. So for this, we're going to use our FK Control Shelf tool. And so we're going to select neck bone 1. FK Control is going to bring up a dialog asking us for a prefix. Prefix in this case is auto-filled to be the selected object, and this is fine. So I'm going to hit OK. That's going to give me 3 nodes. Bring these out a little bit. So we've got 3 nulls that are parented to each other. The first is an offset, which is empty because we don't need to see anything. And this offset is going to be the location of this control. This next one is called auto, and again, it's empty. And we'll use this auto not all the time, and in this case, not for our neck and head, but for our fingers and things like that. We'll use it to populate these transforms with expressions, things like curling of the fingers and fanning of the fingers. We'll do that stuff in this auto node. And that will free up this actual control for animator interaction. And so this is an actual null that has a control object or SOP inside. It's colored green, it's selectable, and it's displayed. So right now this is positioned right at the root of our neck 1 bone. That's where we want. It's really big right now, but we'll fix that in a second. But these 3 nodes can be thought of as a single unit, a little control unit. And it's going to be parented under the chest IK. So if we bring back our spine controls, if we look at this guy, when we rotate our chest control, that neck control is going to come along for the ride. So I'll do the other ones for neck bone 2. Again, the prefix is filled in for us. Oops. Head bone. And the jaw. So now we have these 3 little sets of controls, and we're just going to be parenting them in order because their positions have been set by our shelf tool to be at the root of each of the successive bones. So neck bone 2 offset is going to be a child of neck bone 1 control. Head bone offset is going to be a child of neck bone 2 control, and the jawbone offset is going to be a child of the head bone control. So let's just arrange these a little bit better. If you select some nodes and then with your mouse over one of them, you can use the A key and you'll get this little grid type thing. And if you drag down, that'll just align these nodes nicely. So I can, whoops, I want to make sure you're selecting the right stuff. So with those selected, these selected, now they're nicely aligned. So I'm going to grab all 3 of our controls, and you can see that they're defaulting to a 1 unit size. So I'm going to come to the miscellaneous tab. I'm just going to drop that size down quite a bit. Let's say 0.5 for now. So our neck bone 1 control, we can probably leave it at this size. Neck bone 2 could probably be a little smaller. Let's say 4 or 5, or 4. Our head bone control could probably be a little bit bigger. And then our jaw, we want this quite a bit smaller, maybe even 10.1. But we don't want it to be at the center of our head. It's a little bit awkward to try and select inside there. But we want the pivot point of our jaw to be right here. So what we can do is we can select our jaw control, and on the transform tab, can middle click in its Z parameter and just move it out. Let's see, 0.12 is probably fine. So it's gone negative 0.12 in the Z direction, but we want our pivot to go back to the root of that bone. So we can take that value, 0.12, and we can put it into our pivot translate. So you can see that that put the pivot back at the root of the bone. So now when we select here, we're getting this control. So we have our control objects, and we can rotate them, but they're not doing anything. So we want them to drive our bones. And the way that we're going to do that is with a constraint. So we select the bone object, the thing we want to drive, come up to the constraints shelf and our blend constraint, and whatever it's set to here, we want to set it to simple. We don't care about translation or scale. And we're going to do a keep position after. So we've selected the thing that is going to be constrained, and now we want to select the target of our constraint, which is the driver. And you can see that down at the status bar here, I have now select target objects. You may have that prompt at the bottom of your viewport, but I've moved those prompts to the status bar. So in this case, neck bone 1 is going to be driven by neck bone 1 control, and you can select that either in the viewport or in the network, like that, and then right-click Accept Selection. And this is going to drop you down into that neck bone 1, into a constraints network. And here is the constraint that we've just built. So in this case, for neck bone 1, we've grabbed its world space, and then we've grabbed the transform of neck bone 1 control, and we're blending them, a value of 1, so that means full control. We're blending the rotation. And then we have this little offset here, which will just, in this case, it's not all that important, but if these two things were offset in space, if this control were over here and our bone was here, this offset would maintain that difference. In this case, they're in the same location, so it's not essential to have this. I just like doing it. So I'm going to go up, up. So now on our bone, you'll notice that we have this green little icon with a little wave through it. That's to indicate that we have a constraint on this node. And then you can see we have enable constraints and then the path to the constraint network. If we follow that, you can see that we're inside the bone object, and there is that network that we just looked at. So coming back up, we can select our neck bone 1. And now when we rotate it, we'll see that that bone rotates as well. So now we'll just continue for the other bones. Neck bone 2, constraint, blend. It's still set to simple, still set to rotation, still set to after. Now I can select neck bone 2 control, accept selection, drops me into this constraints network. Everything looks okay. Come back up. Head bone, constraint, blend. Everything is the same. Select the head bone control, accept selection, pops me into this network. Everything looks fine. Back up to soldier. Now I can do jawbone. I can do blend. Everything looks the same. Now I can select the little jaw control, accept selection, and there we go. Now if we select our jaw rotation, you can see that it's rotating our jawbone, and that's bringing the proxy geometry along with it. The same for the head bone, neck 2, and the first one we did. So our head rig is essentially done. We have rotation control of all of our bones. can move our jaw. So before we finish it up, let's start promoting some of our parameters. So we open up our type properties. We can see that inside our head neck, we have display, we have controls, actions, we have the eyes and the jaw that we'll get to in a second. Let's just quickly promote our jaw control. So our jaw control selected. We've got this translate Z and pivot rotate in Z, and that was to move the position of the control from the root here up to the tip of the bone. We can just do a quick clean transform. And I think the pivot rotate or pivot parameters stay that way. But what we want to do is promote this rotate parameter. So let's grab that, drop it on jaw, and it's by default called R2, but we don't want that. We want jaw rot. We want jaw rotate. We can hit apply and accept, so we can see now that that has a relative reference to our parameters. And here it is. And we also want to lock all this stuff off. So again, we can use our rigging menu, rigging shelf, lock all control. So jawbone 1 control selected, lock all, locks everything, but leaves this rotation alone. So that's it for our jaw control. Now we want to do the neck, the two neck controls, and the head control. And then we want to add the controls to determine the space in which this head will rotate. So first, again in our type properties, we're going to add the controls into the head and neck. So neck bone 1 control, we're going to add the rotate. Neck bone 2 control, add the rotate. Head bone 1 control, add the rotate. And now we want to rename these. Neck 2 rot. So neck 1 rot, neck 2 rot, head rot. Apply and accept. Now we can see that these have been promoted. And again, we'll grab these three and use our lock all. So let's lock them all. And next we'll do our space switching. The concept behind space switching is simply giving a control the ability to exist in different rotational spaces. And the way that we can do that is very simple. We can create a null, and we can call it head follows neck location. And then we can make that a child of the head bone control, like that. And then we can keep position when parenting, and we can break that connection. And now this control will be a child of another rotational space. In this case, neck bone 2 control, but its location is going to be at the root of the head. So when we change the parenting of the head bone, actually it'll be neck bone 1, I think. When we change the parent, the position of the head won't change, but where it rotates from will change. So we can also do this. If we copy and paste, we can say head follows neck location, copy paste, head follows center of gravity, paste again, head follows world location. Now with these locations defined, we can parent them to their respective rotations. So head follows neck location. It's going to follow neck bone 1. head follow chest location is going to follow chest control, chest IK control, I should say. Head follows center of gravity location is going to be child of the cog, and head follows world is going to be a child of the master control. Now we can take these four, we can turn off their selectability, turn off their visibility, and just kind of move them over here a little bit. And now what we want to do is we want to drive the headbone1 auto, and we're going to use, again, a constraint for that. But this time, we're not going to use the blend constraint, we're going to use the parent blend constraint. So you can click parent blend, and again, at the status bar, yours again might be at the bottom of the viewport, but mine says select object to create parent blend constraint. So that object is headbone1 auto. So I'm going to select that, and in the viewport, accept selection, or you can use enter. And now it says, now select new parent objects. So I'm going to select head follows neck, follows chest, follows cog, follows world. I'm going to right click and accept. And that dumps me into our headbone1 auto into the constraints network that's been built for us. And this is very much like the other constraint with just some slight differences. So again, we're getting the world space of our constrained object. We're getting its parent space of the constrained object. So that's the actual parent of the constrained object. Then we're getting the locations of the head follows neck location, or chest location, cog, and world. And all of these are being fed into a blend. And right now they're all set to 1, but we'll change that in a second. And then the result of that is sent out as the transform of that object. So we don't want all of these to be on at the same time, and we certainly don't want to have to make our animator come all the way into this network and mess around with this stuff. So we're going to drive these with a simple expression. So if I open up my parameter pane for the head and neck, you can see we have this head space control. And this is going to send a number out. So if it's set to neck, the number is going to be 0. Chest is going to be 1. Cog is going to be 2. World is going to be 3. So we can use an evaluation of that to determine what these should be. So the easy way to set that up is to take the head space parameter, just drag it into this the second slot here. The first slot is for our network parent, and the next slot is for the neck. And right now this head space is set to neck. So I'm going to drag that and drop the relative channel reference right here. And we can see that this blend is being determined by the value that's coming back from this parameter. So if I toggle this to its evaluation mode, you have a 0 because that's 0. But if I change this to world, you can see that that is now a 3. So how does that help us? Well, if we change this back, what we want to do is not simply evaluate this. What we want to do is get this value and then make a decision based on what that value is. So I'm going to extend this out a little bit. What we can do is write a very simple expression. If, open parentheses. So if this value, evaluated from the parameter pane, is equal to, and equal to here is double equals. If it is equal to 0, which is right now what our neck value is. So if this is equal to 0, then the value that this parameter should now have is 1. Otherwise, if it is anything but 0, this parameter should be 0. We can end the if statement with that parentheses. So again, if head space, which is this guy here, is equal to 0 and only 0, then this entire parameter should evaluate to 1. If it's something other than 0, this entire parameter should evaluate to 0. So now I can take that, I copy it. But if we go back to its evaluation mode, we can see that this parameter is sending the value of 0 to anyone who's listening. And this guy's hearing that, putting that value here, comparing it to this 0 and saying, yep, they're equal. So this parameter should be 1. And we can see that it is, in fact, 1. But if I change it to chest, this is a 1 that is being sent from this headspace parameter. So 1 is not equal to 0. So this parameter is going to be 0. So now we can use that for all of these. So again, I can take this, copy it, put it here. And this one is for our chest. So it's actually a 1 that is being sent by this parameter. So if headspace equals 1, then this should be 1, otherwise 0. And here, this should be compared to the value of 2, because that's 0, 1, 2, cog. And finally, the world is a 3. So now, if 3 is being sent by headspace, these should be 0, and they are. And this one should be 1. And so that's swapping the parent between these 4 objects. And we can test that. If we go up and up again. So again, we're telling this headbone 1 auto where its space is for its rotation. So let's bring up our parameters. Let's put that over there. So right now, our head is in the parent space of the neck. So I can rotate my head independently. This guy is rotating, but it's not rotating the head. You can see that the head is keeping straight. But if I go down to neck 1 and rotate it, you can see that the head is rotating with neck 1. And if I go down to the chest, it's also rotating, but it's not rotating because its parent is the chest. It's rotating because the neck is a direct parent or a direct child of the chest. But if I change this to chest, again, this one doesn't rotate the head. This neck 1 doesn't rotate the head, but now the chest does rotate the head. And then we can test the cog. So if the cog is our parent of our head rotation, now rotating the chest does not rotate the head, but our cog does. And if we go down to the world, our chest, again, doesn't rotate the head, but it does rotate with the world. And something's wrong there. I'll fix that in a second. But you can see that using this control, we can determine the space in which the head rotates. In testing the head rotation, I noticed that if we set that to world and select our master control and rotate, the head is rotating with the world, but the whole neck and head isn't moving with the spine. And the reason is that, as always, I've forgotten something, and that is that this neck root needs to be constrained so that it will follow the spine. So we'll do that next. To ensure that our neck and head bones move with our controls, we're going to constrain the neck root to this neck bone 1 control. So we're going to select that. We're going to go simple blend, turn on everything. Key position after is fine. And now we can select that control, accept selection. Now, if we rotate master control, everything follows along just fine. Here's our cog. If we set that to chest, head rotates with cog and with the chest. Set this to cog. The head doesn't rotate. Before we move on to our eyes, let's just do a little bit of cleanup here in our network. All of these guys, we want to lock their transforms. And in addition, all of these autos, we want to lock their transform, including this head bone auto that has the constraint. So we're going to grab all those, and we'll come to our rigging shelf, lock all. And then the neck root, we don't need to be able to select it. We don't need to see it. And we want to lock it. Let's just see our jaw root. Don't need to see that or select it. And we want to lock it. And all of these, we don't need to see them or select them. And we also want to lock them. So there is our neck and head rig done. And next we'll move on to the eyes. Our eye rig is fairly straightforward. We're going to have a bone for each eye, and then parented under that bone is going to be a piece of proxy geometry. And then each of those bones is going to be constrained with a look at constraint to one of these little eye look at nulls. And then these look at nulls are going to be the children of a master control to move both eyes around at the same time. This master control will also have an eyes follow parameter. So in this case, it's following the head. So if I rotate the head, that look at will follow. Or I can switch it to world, in which case the eyes will remain looking at that look at control no matter where I put the head. You can get this kind of thing going on. To start, I've gone in and made groups of the eyes. And actually, to be honest, I stole these eyes from our test geometry Tommy character. That's why it's got some textures on them. And what we're going to do is snap a null with a bone to the center of this left eye. So to start, I've used the same technique that we did with the jaw and the rest of the head and created a left eye proxy and a right eye proxy, locked off their controls. And inside, again, object merged, locked. And just here on the left eye, I've added a sphere with the object merge as its input. It's just a primitive sphere. And what that will do is the dimensions of the sphere will be inherited from the size of whatever's coming in. So now we have this sphere centered right on the eye geometry. And now if I go up to the object level, I can throw down a null. We can use this centroid expression. So in this case, I'm asking for the centroid of what object, the left eye proxy, and then I'm looking for the dimension in x. And if I put that in, it'll give me this little value. So now this null, which is currently down there by the origin, has shifted over that amount. So then I can take this tab over to the y, dimension y. You can see that it's hopped up. And again for z. And now that null is right in the center of that sphere. I can make the display geometry much smaller. And so now this null is at the right location for this left eye. I'm going to call this left eye root. Then I'm going to make a bone, not in the viewport with the bones tool, but just create a bone here in the network and parent that to the eye, the eye root. Now you'll see that it's default of 1 unit, which is 1 meter, and it's pointing in Z here. So what I can do, the eye root, throw that to 180, then on the bone, I'm going to make it much smaller, and it's just going to poke just out the front of the eye. And we're not going to be doing any sort of capturing with this bone. We're just using it as an indicator. Whoops. So I'm just going to poke it out just that much. It's purely for visualization. And then I'm going to call this left eye bone. And now that we're doing things on our left side, like all this time we've been doing things in the center for our spine and our head and neck. And the naming conventions we've been using haven't involved any left or right nomenclature, because we're not going to be mirroring any of this stuff. But now, with the eyes, or starting with the eyes, we're going to be doing things on our left side and then mirroring what we've done over to the right side. So the naming convention is going to become very important because the mirror tool here at the object level is very smart, provided it's given the right kind of names. So we'll see that right now. So now in the left eye proxy, I can get rid of this sphere, put the display back on the out node. So there's our eye. There's our eye root null and our eye bone. And I'm going to parent the left eye proxy under the left eye bone. So now when we rotate this null or the bone, the eye will rotate in the head. So I'm going to turn off selectability and display of the left eye root. I'm going to delete the channel on translate, and that will leave the values. Then I'm going to grab that, just do a clean transform, and then I'm going to use our shelf tool, lock all, because we're going to be moving the eye with the bone and not the null. So with these two selected, I now want to mirror them over to the right-hand side. And to do that, I'm going to use the mirror tool. So in the viewport, I'm just going to type mirror, and at the bottom here in my status bar, it says select one or more objects, then press enter to continue. But I'm going to select in the network and accept, and it mirrored the right eye and the left eye, or the eye root and the bone. So I'll do that again because I want to show you. Let's just get rid of this stuff for a second. We'll turn off those bones. Turn that off. So when you use the mirror tool, up here at the top, it'll ask you what new prefix you want. And in this case, I'm using R underscore, and that's going to replace this left underscore. And so that's why this naming convention is very important. You want something, you want a prefix on your nodes that makes sense and also accommodates this usage here. So it's going to give me a new prefix. It's going to remove the old name up to underscore. So it's going to remove that. I'm mirroring on the YZ plane. And now when I select these guys, you can see that I get this little preview of the new nodes that I'm about to create. So it's not showing me the null because I've hidden it, but it is showing me the new bone that's going to be created. And this is very helpful because if this were showing up over here somewhere, I would know that I need to look at what my mirror plane is and what's going on. But here it's showing me that it's going to mirror to the right-hand side. So again, accept selection. And now we have a right eye root and a right eye bone. I can turn that on. Let's see. And so they're named correctly. They're in the right space. And everything is good. So now I can take this right eye proxy, turn it back on, and mirror it to that. Whoops. What have I done here? I don't have keep position when parenting on. So I'll unparent that. Keep position when parenting. Parent it to the bone. Turn that off. Now that we've done that, rearrange this a little bit. And we're going to parent both of these roots to the head bone. So we can select both, parent to the head bone. Whoops. Keep position when parenting. We can turn this back on. So now, when we rotate our head, our eyes are going to follow. But we also want these two bones to look at some kind of control out here. And so we're going to make 3 controls, one for each eye individually, and then one control for both collectively. So again, we're going to use our FK control. Oops. Do die root, So this control is going to be the left eye control look at. So I'm going to say left eye as the prefix. And so here I get left eye offset, left eye auto, and left eye control. Do the same for the right eye. So right eye is our prefix. And we get right eye offset, right eye auto, and right eye control. And right now, these are big giant spheres or circles at the position of the eye. So I'm going to take both of these, I'm going to change them to nulls, and I'm going to make their size quite small. Something like that. So right now these are at the position of the eye, but we want them to be somewhere out here. And this is really up to you and your character. So I'm going to take both of the left eye and right eye offset, and I'm going to translate them. Yeah, something like that is fine. It really doesn't matter. You don't want to put them out to the left or right. You just want to move them out in Z. And whatever you think is good for your character. And so with these two selected, I'm going to clean that transform. So that's the position of our eyes. If we had any constraints or scripts or something, we could put on the auto controls, and then the right eye control and left eye control are going to be for our individual animation. So now we need a third control, and that will be a parent of both of these. So in this case, I'm just going to take this right eye offset just to give me something to make a control with. And this one is going to be called eyes. Now I can click that. So now I get an eyes plural offset, eyes auto and eyes control. Take that and put it up here. And right now it's centered on that right eye offset because that's the one that I had selected. But we actually want it to be dead center in between the two of these. So I'm going to take this offset control and I'm going to go to its pre-transform here and say extract pre-transform. So you can see this is the location that it needs to be here. But I want it to be 0 in X. So that places it right dead center. And then the control itself, I'm going to say planes, and it's on the XY plane, and then I'm just going to make it small like that. Use the display scale to do that, not the transform scale. So now I have a little sort of box thing that the animator can grab, and that will move both of these. So with right eye offset, keep position when parenting, left eye offset, keep position when parenting. I take both of these, make them a child of the eyes control. So now when I select that, I move both of these around. And actually, before I do that, I'll cut that. Let's just fix this orientation. Extract that, retransform, 180, clean that transform. So now this is oriented properly. Parent those to that. So now this guy is going to move both of those individual controls. So now what we want to do is we want to constrain the right eye and the left eye to their respective individual controls. And we'll do that with a constraint. So left eye bone, go to our constraints. We're going to use the look at constraint. So when I click that, it knows that I had selected the left eye bone. So now in the status bar, it says, now select look at object, if any. And in this case, the look at object is that guy. I'm going to hit accept selection. Now I'm prompted to select a look up object, if any, and press enter. Don't have a look up object, so I'm just going to press enter. Now it's given me a simple look at constraint. So now if I go up and up, we can see that that bone has a constraint on it. And if I move the left eye control, you can watch this left eye. So that left eye now moves. and it will move when I drag both of these. So we'll do the same to the right eye. Select the bone, select the look at, select the look at target, enter to accept, enter to accept, and now, whoops, got a little reversal of our eye. We can go into our constraint, and we can say Z positive. And now both of these eyes follow along. We'll take this left eye control and we'll leave it as green. The right eye we'll make red, just so we can distinguish them here. And this guy we'll make blue. It's nice to differentiate your left and right with colors, and then have another color for sort of more central things. We can do that later to our spine and head. So next, we'll do the space switching for this control. Just as we did with our head control, when we put a constraint on the auto null, we'll do the same for our eyes auto here. First, we're going to make a couple of nulls. We're going to call this, and I can Alt click and drag to create a new one. Eyes follow world location. Right now these two are down here at the origin. I want their location to be here at this main control, so I'm going to select both, and they don't have key position when parenting on, so they snap to this new location. Now, both selected, I'm going to turn on keep position when parenting, and I can break that connection. And now, this guy is going to get a constraint to both of these. So, with the eyes auto selected, I'm going to go to my constraints shelf, parent blend, simple, full transform, keep position, and down the status bar it's saying select object to create parent blend constraint. So that's this guy. I can accept. Now select new parent objects. So that's the eyes follow head location, eyes follow world location. Right click, accept selection. So again, it dumps us into the object that we've constrained into its constraints network. So we have a get world space, we have its get parent space, eyes follow head, eyes follow world. Those three are being blended. And right now, all of them are fully on, but we want to reuse that same expression that we used for the head control. So we can go in and remind ourselves what that looked like. So we were getting a value and comparing it. We'll take that. We'll reuse it here on this blend. And this time, we want to use the eyes follow parameter, which we should actually change the wording here. We'll go back and fix that. But for now, we can still use this parameter. So I can paste that expression in. So now it's still looking at head space. But now if I mouse over eyes follow, you'll see E follow. So I want to change this to E follow. So if eyes follow is equal to 0, which would be that one, then it should be 1, otherwise 0. And otherwise is 1, otherwise 0. So this works if we, right now our eyes follow is on 1, so it does work. If we change that to 0, they switch. But our wording here is wrong. So let's change that real quick. We go to our type properties, go down to our eyes. We have our eyes follow parameter, and we're using a menu, but our token and label are wrong. So our token's okay, 0 and 1, but our label is incorrect. So 0 should be head, and 1 should be world. Hit accept. And if you get this little warning. This is essentially saying that there's a path to a node that's unresolved. You can just hit OK, but keep an eye on this. So we're going to go down into constraint path constraints and see what's going on. And I think it might be this is wrong. What does that say? eFollow. It should be right. To test that, I'm going to grab this eyes follow parameter and drop it into this blend 0 just to see what I get. So relative reference. Yeah, so that should be fine. So now I'm going to break this delete channel. Put that back to 1. I think we're okay. So if we look at the values we're getting here, if we're on head 1, if we're on world switches, I should actually change the default of this as well. So we'll go down to eyes follow. We made this correction. And now we can go to channels. See the default value here is 1, but we want that to be 0. We'll hit accept again. Getting this warning again. I'll try and find out why that's happening. I don't think it's causing any problem. So now, if we head back up, we can take these two nulls and we can turn off their selectability, turn off their display. We want the eyes follow head to be parented to the head control, head bone 1 control, and then the eyes follow world to be parented to our master control. So let's test and see if this works. So right now, the eyes are following the head. So if I rotate the head, this blue control should move, and that will move the two inner controls. And sure enough, it does work. Now if I change this to world, so nothing changes, but when I rotate the head, you can see that the eyes, ooh, looking over there, ooh, looking over there. So you get this sort of creepy look. So that works fine. We can go in and select these bones. We can turn off their selectability and their visibility. These roots have been locked off. That's good. Proxies are locked off. Eye offset. We can leave this stuff alone, or we could clean the transform. Either way, we're going to lock it. Go back to our rigging shelf. Lock all. Our eyes auto. Again, we're going to lock that. Eyes control, we need to promote the transform of this. Right eye offset should be locked. Eyes auto should be locked. And the right eye control, we're going to promote the translate and the translate on the left. So let's do that now. Go back to our type properties. So here, head, neck, we have eyes. So now we have these display options, so we need a little folder for our controls. So we'll add that. This. Again, that's a simple tab. I'm going to call that controls. And then we want our master eye control. We want the translate of that. Call that. And then we have left eye control. And right eye. So we have an eyes control. We have a left eye control and a right eye control. Hit accept. So now on these nodes, we have our translate is promoted, but we want to lock everything else. Right eye control, translate's promoted, but we want to lock everything else. Left eye, lock everything else. And there is our eye control. Before we finish with our eyes, we need to set up the display properties to drive the visibility and selectability of the stuff. So right off the top, we have GeoDisplay, and our default is proxy. So again, we want to drive this depending on what kind of geometry we're showing. And we can steal that right from here. If we select the jaw proxy, we can grab this expression that we did, and we can drop that right into those eyes. Again, render tab, display, and then you can see that this one is EG display for eyes geo display. So we can change that H to an E. And now we can turn the geo display off for our eyes, proxy. And then if we have high resolution eyes, maybe for our deformed geometry, we can have the proxy geometry disappear. So proxy by default. And then we have the controls display off and on. We can grab all three of these, go to the render tab, turn on the display parameter, drag the controls display, drop it right in there, relative channel reference. So now we have that guy, and we can turn all of those off or on. We've done our eyes follow. Next we'll do this eye line. We'll build the geometry that will make that little dotted line, and then set up the control to turn that off and on. To build our eye line, we're going to measure the distance between the root of our eye and our little eye control, and then we're going to make a polygon line of that length, and then we're going to break it up so that even when this thing moves, that length will be recalculated and our line will update. So if we go inside of our left eye control, and I've turned on points so we can see what's going on a little bit better. What we want to do is we want to merge some new piece of geometry in with this control object, and then using this eye line control, we're going to drive a switch. And we're going to switch between when the eye line is off, and that should be the default. Let's just change that really quickly. Eye line, channels, default is 0. So when the eye line is off, this switch is going to use input 0, and we can hook this up right now. Relative channel reference. So the eye line is off, the switch is 0. Eye line is on, the switch is 1. So we're going to switch between just using the regular control SOP and whatever comes into this merge. And the merge is going to be the original control SOP plus the little line that we're going to make. So to make this line, I'm going to use, we're going to object merge our the point that is inside the null of our eye root. So in this case, that's going to be where's our eye root? Eye root, point 1, export relative path. And we're going to transform it into this object. So now you can see, put on point numbers. You can sort of see it right there. So that's the merged point from the root null of our eye. So now that we have that, we can use another merge and merge these two, whoops, not that one, this point and this point together. And let's hide other objects. So now we have this point, which again was from our eye root, and we have this point, which is from our eye control, and then we want to just make a line between them, and the easiest way to do that is with an add SOP. So in this SOP we have 2 points, throw it into an add SOP, and we can say polygons by group, and you can see immediately we now have this line. Now we're going to resample that line And by default, you can see that the line's been resampled using a maximum segment length. But we're going to turn that off. I'm going to turn on maximum segments. And the difference here is that this length will accept a float value, but maximum segments is expecting an integer. So if we measure this, curve, this line with arc length, we're probably going to get a float. So we're going to have to probably multiply this up into an integer, or at least something that can be rounded to an integer. So we use the arc length expression just as we did with our spine. And the SOP we want is in this network, and it's that add 1, primitive 0, from 0 to 1. And then we're going to multiply it by, let's say, 30. And so now we get our segments. And if I turn on Goes to Other Objects, this control here is we're measuring the distance between this one and the eye. I'm going to move this master control, and you'll see that as I do, the line increases its length, and then also the segments increase. So the segments try and maintain their size, no matter how long this curve is. So we're going to use that with another add SOP, and in this one, we're going to delete the geometry, but we're going to keep the points. So we had geometry from the add SOP, then we subdivided it with the resample. So that gave us the right points. Now we want to get rid of those points and then make new polygons by going over to the Polygon tab, by group, but we're not going to use all points like we did in this first add. We're going to use groups of n points, and by default that's set to 2, and that's exactly what we want. So now we have a little dashed line that each of those dashes will maintain their size no matter how long that line becomes. And if you want these to be a little smaller, you can just multiply that arc length by a higher number. Whoops, that's a really high number. Let's try 35. So that's a little smaller. Let's try 50. That's smaller again. And this network is very fast, so you don't really have to worry about any kind of speed hit for this. So we'll turn off point numbers. We'll turn off the display of points. Now we have our line. So coming back to what we originally had, we have our original control, just this guy here. And now we've built this new line, whoops, using the point in this control and the point coming from the eye root. So we have this dashed line, and we want to merge those two together. So now we have the null that has an attached line. And then we want to drive what to display with this switch. And as you can see, we have the eye line is off, eye line is on. So what we can do is we can take all of this and we can copy it. We can go over to the right eye, make some room to paste it. You can see that everything hooked up again because the names of these SOPs in our right eye control are the same as they were in the left eye control. So everything found the things that it was hooked up to before. So all we have to change is this object merge, because right now this is bringing in the left eye root, but we want the right eye root. So right eye root, and our eye line is still driving this switch, so we can turn on and turn off. So if we go back up to the object level, we can turn them on, we can grab that, we can move it around, and you can see that the line follows exactly where we want it to, showing us where our character is looking. But if I move way out, see that that line gets as long as it needs to be, and the segments maintain their size. So we don't get little tiny segments here and really, really big segments here, but we always get a constant segment size. So I'll put that back to default. And it looks like, we turn that back off, it looks like we are finally done with our head and neck. So we have display controls for the head and neck. We have controls for the head and neck. We have eye controls for display. We have eye controls, jaw controls. So next time we'll be doing our left arm, and hope to see you then. Thanks.